Hey Paul, how's it going?
Yeah, good things, Matt. Bit of an exciting announcement that came out today.
Yeah, we're getting up to like Christmas season, right? So all the good stuff's coming out. So pretty excited about this one. Let me just see if I can share what I am talking about with everyone in the group. So I'll just pop it up here. But yeah, Lambda now runs on Graviton 2 if you want it to run on Graviton 2. 34% better price performance, 19 better performance, percent better performance. You can provision it with CloudFormation and CDK as well. We've made a little bit of an attempt at this. This is all hot off the press. You can go up to 10 gigabytes of memory and you can use 6 vCPUs. What are your thoughts, Paul? I know you've played with it very, very quickly today when it first got announced.
Look, I think that you and I both think that using ARM and using Graviton and AWS Custom Silicon is a good idea. You get better performance for a cheaper price. So yeah, I was really excited to see this come out, and like you said, and even internally to AWS, we were discussing this today, and we were saying, how do we go ahead and do this, and let's prove that we can deploy as easy as possible as we were before Lambda functions into ARM. And so that's what we thought. We'd set up a quick little episode today to show you what that looks like within your instance, and to prove that yes, it is an ARM CPU behind the scenes there. And interestingly, we found one specific point that we'll call out when we get to that point within deploying basic functions, even with 128 megs of RAM. So
Yeah.
Matt, I think there you've got the Lambda console open.
Yeah, I've got the management console, and let's just see what it looks like within the console, right? And then we'll have a look
Yep.
at some of the other options in a second. So I'm going to create a new function. I'm going to call this Lambda test, very original name. I am going to do mine in Python because I think you've done some stuff in Node.
Yep.
And you can see here at the very first start, you can choose the architecture. So I'm going to choose ARM64. That's going to use the Graviton instance. And I'm going to go and create a function. We'll give it a quick test. I know most people aren't creating lambdas in the console when I talk to them, so really keen to flick over to you, Paul, later and see what you've done there. But let's just do this as a start so we can prove that it works in the console and see it working. So I'm going to test this lambda. Just create like this test event. I'm really lazy when it comes to these things, and I'm excited to just test what I've got. Hello from Lambda. So I know I created as an ARM Lambda. If I go into configuration, I can boost up the memory if I wanted to here. So if I go 10 to 40, and this should give me 6 cores and 10 gigs of RAM effectively. Now, have they put it anywhere in terms of knowing what I'm running on architecturally as well? Can I see that in the console?
You should be able to see that. I think if you go to, where is it? Let me have a look.
Well, I can just code it up, right? We can test it just by doing some extra Python. So maybe I'll do that to start. So what I want to do is I want to import the OS library and the platform library, and I'm just going to get rid of the JSON dump here. And what I'm going to do is I'm going to go let's go platform dot processor. So if I return that, so I'll do a deploy and I return that, I should be able to see that I'm using a Arch64 platform. So that kind of tells me that I am using ARM in the background. So if I wanted to dive one layer deeper into that, what I could do is I could do a platform.platform in Python. So platform.platform. And if I deploy and test, I should see a bit more information. So here we go. So I've got Linux. It's definitely 64-bit ARM. So that's looking good. And then the last thing is I probably want to have a look at the cores, right? So that's why I added OS in before as a library. So I'll just go cores and OS. Let me remember this. This is OS dot CPU count. But I think I need to stringify this as well, right? So, because this is going to be returned as an int. So I'll just go string and blah. And let's test this out. Did it work? No, I've done something wrong. What have I done? Let me just have a quick nose. So string os.cpu count. That looks pretty okay. I'm just missing a plus. It's always something grammatical, right?
Something to do with string concatenation. Yeah.
Yeah, there we go. So cores equals 6. So I've got a 6-core ARM instance right here, right? Pretty awesome. So that's just doing it from the console. What I might do is I'll stop my screen share and we'll have a look at your side and see what you've done in SAM, because you've done some modifications to the SAM template, haven't you?
Yeah. So what I'll do is so is my screen up at the moment, Matt?
I've just pulled you up. Yep, there we go. So yeah, VS Code.
Yeah, so I used SAM, and SAM's the serverless application model to deploy like a standard Node.js function. Try to bring up my terminal here. Yep, here we go. So I'll just move these out of the way. Basically, like this is like the stock standard function that you're going to get with the quick start that says hello world, except what I've done is include or import file system to be able to read proc CPU info and the OS library that enables me to get some information around the operating system itself. So what we should be able to see is once I deploy this function. Now this function here at the moment is just on normal x64. So if I go ahead and was to load that API, reload that, we'd see that the vendor ID within the Lambda function is genuine Intel, CPU family 6, model 63, some other CPU megahertz, some information about the CPU. CPU cores is 2 for what I've got at the moment here. And here we go for each of those CPUs. We can see like what we have specifically access for. And in this, I've set, if we look at the template, the memory size to 128 megs RAM. So what about if we wanted our SAM application, or what does it look like within CloudFormation to be able to switch that architecture? So it wasn't straightforward in the blog exactly what to do, but I went and had a look at the SAM repo, and I looked at the last commit, which was just a few hours ago. I saw immediately that it was like you add this extra property under your function, so which is architectures, and the architecture is like ARM64. I mean, it takes an array, so I'm not really sure what happens if you try and pass in 2.
Yeah, I was like, you could probably pass an x86 maybe, and then that way you can use either or, right? But
yeah, I'm not sure what happens there, like or what would happen there. Interesting. Maybe we can try it in a second.
Yeah, later. Yeah, but I mostly care about the ARM stuff here, right?
Yeah. So, however, you can see that like the syntax highlighting is picking up this architectures as an error. It's not going to work there. I've deployed this one, so let's SAM build and SAM deploy it again and see what happens. Actually, I forgot to save the template file, so it's just we'll let that deploy and build happen. It'll only take a second.
Yeah, it's okay.
I'll cancel it out. So SAM build and SAM deploy that, and we'll see that immediately I have some errors. So I've got some errors here, which probably means that the SAM CLI is an update and hasn't included this. So I went and I checked that, and the latest SAM CLI update was 1.3.2, which was about 9 days ago or so. But I really wanted to deploy my SAM functions and start playing with this today. So basically to get around that for the moment, sort of had a look at where this error is coming from. And it's saying property architecture is not defined on that resource function. So there's a problem. It's throwing an error. It's throwing an error on in this specific file on line 102. So to fix that, I know the rest of my document is okay. If there's an error that it finds, it's going to throw an error. Let's ignore that for now. If we just completely ignore that error, which would, this would fail on any type of error that you were to put in your SAM template. But for now, that's fine. We'll just presume that that's okay. I'll build that again, and we'll see that even though there was an error, because it's not in that, because it's not being caught there or throwing an exception, it goes ahead and builds out that CloudFormation. That. So if we were to look in ours here, we will see that template file is going to be in there. It's going to be like all as we expect it to be. So here is that CloudFormation that's going to be set up there and deployed. So that has gone and packaged up my application. It's doing the update at the moment, and we should see that in just a second. Oh, the update's complete now. That if I reload this same API, I should see that change. And so I do see some changes immediately, straight away coming in. I see the OS here is ARM 64, so I know that I'm on ARM processors, and the model of those CPU is like listed as unknown, so it mustn't be pulled out of that application. But here we can see that this is how I can deploy a node application using SAM by altering that template itself. The same thing we'll see to confirm if I do 10 to 40. Will I get my 6 CPUs? Will it work the exact same way that it did for Matt in the console? And we should see that come up in just a second. So I guess it was interesting to see that even with 128 megs of RAM, I had access to 2 CPUs. Not what I would have expected, because I thought it was only 1 CPU when you're all base. So that was pretty interesting. But we should see access to 6 cores or CPUs once that's gone ahead and deployed. So.
Just again for everyone, what version of the SAM CLI are you on, right? Because we're expecting in the next day or two there'll be an update, and just so everyone knows like what the version is that you used to kind of do that workarounds, the next version after 1.32 should be the one that I'd say will work out of the box, right?
Should work out of the box, and this was the file. Like you can follow the debug messages to figure out what to go ahead and change. If you want to go ahead and alter that and move that out of the way if you wanted to deploy it. Obviously, that's going to break if you've got it in a pipeline, but for local, it should work just fine for testing. I would be surprised if someone's going to deploy ARM Lambdas today into production. I mean, you never know, maybe.
If they're anything like us, like they would have rolled everything out.
They might, yeah.
Yeah, maybe.
So I've made a change that to this. So I'll push that out. We'll see how that works. By the way, see that's Node 14. Not every runtime is supported at the moment, and I also don't have a container here, but you can do it with containers as well. So it's supported for containers as well. I would assume that if you are building with containers, there's probably a different base container that it builds off, unless they made that base Lambda container multi-arc. Maybe they did. Do you have that blog post up? And maybe we'll have a look at that in just a second, Matt.
Yeah. The Lambda functions Graviton release. I've got that in the background.
Yeah, so that's updated now. Let's just see, do I have more cores? Did I not save it? Oh, I didn't save the memory size. That's a shame. That's annoying. I'll just do something in here to make it force a recompilation so it knows how to put something else up. But yeah, I think it was this repository. So it was the SAM CLI. This is where I was seeing the latest release is 132. And if we were to go to let's get up SAM. Here we go, the serverless application model. This is how I was able to quickly sort of have a look to figure out what was happening without the diff. I saw that feature request ARM support was merged in. I had a look to determine exactly what it was to look like. I looked at some of the tests and I saw that where was it? Here we go. So here's where you see, look, it looks like you can pass it in there. So, I mean, I don't know what happens if you do that. I mean, I don't know. I'll try.
It must be like either or, right? Like based on whatever's available.
Yeah, I'll try that in just a sec. So anyway, we'll reload this because that's deployed. We should see, yes, I got my 6 cores that are available to me. Just out of interest's sake, like let's like redeploy that and put in both. Like maybe that just says whatever's available, or there's some ruling around that, what it does. I'm not really sure. I'll just do something in here. Force that to rebuild. Yeah, maybe it just works for either. For this application, it's going to work because I guess the base underlying like architecture has got Python compiled in for that specific variant. That might be, you have to be careful and have a multi-arc container. Yeah, I don't know. It didn't like it.
I wouldn't actually do it. I was just actually looking at like the runtime settings in the console, and it's an either or option in the console,
Yeah.
right?
Yeah.
So maybe it's something that they're planning in the future is if your container supports both and you've got two separate images, one for each or whatever.
Maybe that's what it is actually. Maybe that's
Yeah.
exactly why you can use it for that. But it's saying here the generated CloudFormation fails, and it specifically says it should be, either x86-64 or ARM 64. So, well, at least we know that. But yeah, Matt, like pretty interesting. You want to go back and we'll just summarize off the end of that blog post?
Yeah, exactly. I'm just putting it up now. So, like, if I scroll down, there's a lot of different examples on this, right? But one of the things that I did see was like the runtime settings, right? You can either choose one or the other, which is why I guessed that only one will work for now. So, must hopefully be something in the future there. Container support is there. There's some example codes. If I keep scrolling down, let's just see, make sure that we haven't missed anything that's quite exciting. So I think there's some performance tests that you can potentially do as well. Some more example code. Yeah, like they've really well documented this, I have to say. Like just showing like all the different things that you can do with it and all the tests that you can do, like to play around with it. But yeah, this is probably the part that I thought everyone would be interested in, right? Like,
yeah.
So it's North Virginia, Ohio, Oregon, Frankfurt, Ireland, London, Mumbai, Singapore, Sydney, and Tokyo. So we're running ours out of Sydney.
Yep.
My one that I attempted was with Python 3.9, but I could have used 3.8. 12 and 14 Node are supported, not 16 yet. Java 8 and 11, .NET Core 3.1, Ruby 2.7, and Amazon Linux 2 custom runtimes.
So PHP supported there.
Yeah, so pretty cool. And Swift and anything else, I'm guessing. Yeah. You do have to use Amazon Linux 2. I think that was one of the other things that is called out, but that's been like that for a fair amount of time, I believe, like in the Lambda world. Yeah, very nice.
Yeah, so yeah, I'm excited to go ahead and continue to use it. I mean, if you think of a 34% price performance decrease, pretty great, right?
Yeah, amazingly great. So everyone, I hope you enjoyed the session. We just wanted to keep it short today because we're excited about this particular feature. And we'll catch you 12 p.m. AEST time every Wednesday, or subscribe to our YouTube where we'll have this video if you want to have like little snippets like this when we get excited about particular things. But yeah, thanks everyone for now.
Thanks, Aaron. Bye.